Hello students, good evening students. Now I am explaining you shape of the molecules. Few examples I will explain you. Those examples are here: BeCl2, CO2, CH4, ammonia, H2O, and PCl5, SF4, ClF3. These are the examples, and SF6, XeF4. These molecules, how they are existing with shape. Here the BeCl2 shape is linear. Before videos, I will show you already the shape of the molecules. Once again, look at the shape of the BeCl2. Here the BeCl2 shape is linear. Here this is the beryllium, central atom, here the chlorine, here the chlorine. So around the beryllium, two chlorine atoms are existing. The shape of the molecule is what here? The linear, the shape of the molecule. What is the bond angle here? 180 degrees. Between chlorine, the bond angle is 180 degrees. The shape of the molecule is linear. Now next molecule is CO2, carbon dioxide. Here this is the structure of the carbon dioxide. Central atom is carbon, surrounding atoms are oxygen. Here between carbon and oxygen double bond is present. The double bond existing like this. Here the sigma bond, there is a pi bond. Sigma bond, pi bond. Observe here the bonds, how they are existing. One is vertical, another one is horizontally existing. This bond and this bond existing, observed here, vertically and horizontally existing. CO2 molecule. What is the shape of the CO2 molecule? Observed here, all the atoms are existing in the same plane or a different plane? Same plane. So all the atoms are existing in the same plane. The shape of the molecule is what? Linear. The shape of the molecule is linear. Bond angle is how much? Bond angle is 180 degrees. This is the CO2 shape. Next, observe that methane molecule. Here this is the shape of the methane. Here in the methane molecule, central atom is carbon, surrounding atoms are here hydrogen atoms. The bond angle between any two bonds, if you are observing the bond angle any two bonds, between any two bonds, the bond angle is 109 degrees 28 minutes. This is the tetrahedral arrangement. The shape of the molecule of methane is tetrahedral arrangement. Next molecule is ammonia. How it is existing ammonia? Ammonia is existing like a pyramidal arrangement, like this. Ammonia is like a pyramidal arrangement. This is the shape of the ammonia, pyramidal arrangement. Nitrogen is existing above. The below, three hydrogens are existing like this. Three hydrogens, like Egypt pyramids arrangement, like that. This is the shape of ammonia arrangement. Next molecule is what? H2O. H2O's shape is angular arrangement. The angular arrangement is existing, the H2O existing like an angular arrangement. This is the shape of the H2O. Here the oxygen, hydrogen, hydrogen. H2O existing with angular arrangement. The bond angle is here 104. In the ammonia, what is the bond angle in the ammonia? 107. Between any two bonds, the bond angle is 107. In the water, in the angular shape, the water, the bond angle is 104 degrees. 104 degrees. Next molecule, what is that next molecule? PCl5. PCl5, observed here, this is the shape of the PCl5, students. PCl5. If you are observing the PCl5 molecule, here this is the phosphorus, chlorine, chlorine, chlorine. Three chlorines existing in the same plane. Here this chlorine, this chlorine, this chlorine present in the same plane. It is look like, observed here, sidewise, observed here, trigonal planar arrangement. It is look like trigonal planar arrangement. One chlorine above the plane, another chlorine is below the plane. This is the PCl5 molecule. It is a non-planar molecule. Non-planar molecule. Methane is a non-planar molecule. Methane is a non-planar molecule because of all the atoms are not existing in the same plane. PCl5 is a non-planar molecule. Ammonia is a non-planar molecule. So here one important point is existing in the PCl5. Look, observe here, this bond is look like longer bond. This bonds, these three bonds, this bond and this bond look like shorter bonds. Here these bonds are axial bonds, these bonds are equatorial bonds. In the PCl5 molecule, these three bonds are equatorial bonds, these two bonds are axial bonds. So axial bonds are longer bonds and equatorial bonds are shorter bonds. This is a PCl5. Next, this is another example of another molecular arrangement of methane molecule. Here the carbon, hydrogen, 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 hydrogen. All the atoms are existing in different plane. It is a non-planar molecule. Next, one more example, the shape of the molecule SF6. If you are observing the SF6 molecule, how many fluorine atoms are there in the SF6 molecule? Here, if you are observing, central atom is sulfur, surrounding atoms are 6 fluorines are existing. Here, if you are observing, look like 4 fluorine atoms are same plane, this fluorine, this fluorine, this fluorine, this fluorine, same plane. Observe carefully, observe carefully. This fluorine is above the plane, this fluorine is below the plane, but all the bonds are equal bond length, all are equal bond length. That is SF6 shape. SF6 equal. This is octahedral arrangement. This arrangement we called as octahedral. Octahedral. Next molecule, square planar. This is square planar. Square planar means 4 bonds. Here the central atom, fluorine, 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 fluorine. This is the xenon. Xenon, fluorine, 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 fluorine. One lone pair is existing above the plane, another lone pair existing below the plane. All the atoms are existing same plane. It is called as square planar arrangement. Next, this is which molecule? It is look like BF3, boron trifluoride. This is the boron, fluorine, fluorine, fluorine. It is look like trigonal planar arrangement. All the atoms are existing in the same plane. All the atoms are existing in the same plane. This is planar molecule. Bond angle is 120 degrees in the BF3. Bond angle 120. Here what is the bond angle here? In the SF6, 90 degrees. Perpendicularly existing, 90 degrees. Here the 90 degrees. The question previously asked based on this, how many 90 degrees bond angles are present in this molecule? How many 90 degrees bond angles are present in this molecule? So these are the few examples, students. Identification of shapes of the molecules. So shapes of molecules, identification, shapes. This is carbon dioxide. This is carbon dioxide, linear shape. This is XeF4, XeF4. This one is SF6. This is SF6. And this one is methane. This is the methane molecule, tetrahedral arrangement. This is BF3. BF3 is the trigonal planar arrangement. And this one is PCl5 molecule. PCl5, what is the shape? Trigonal bipyramidal. Trigonal bipyramidal. This is trigonal planar. This is tetrahedral. Tetrahedral. What is the shape of the carbon dioxide? Linear. And what is the shape of the XeF4? Square planar. This is XeF4, students. XeF4. This is SF6 molecule. SF6. Sulfur hexafluoride. What is this? This one is BeCl2 or CO2, linear arrangement. Okay, students. Bye, students.